All right. Well, good morning, good afternoon, good evening from wherever you are, who's joined us today. This is a moderated panel discussion for a session that's titled "The Role of Smart Buildings in Reducing Carbon Emissions." And we have a great panel here, and we're looking forward to an interesting discussion as well as some short presentations. I want to provide you briefly a little context first, because some people may be saying, why are we talking about this at a Smart Buildings conference? And I will make that clear here in just a second, once I get myself set up to share. Okay, so, whoops. Smart buildings, the value proposition, traditionally when we talk about it, or when I've spoken about it, we're all talking about how do we improve, the experience for occupants in the buildings, visitors in the buildings. How do we, enhance that experience through whatever that deployment of smart building technology or capabilities is. We look at improving the operational efficiency and the safety of the buildings, and really, there's a business opportunity associated with that. And so, how does decarbonization fit in? And so one of the arguments I've made, which we may or may not expound on here, is really that, a decarbonized building, particularly in today's climate, is probably a foundational aspect of what I'd call a smart building. It's like, never mind, all the other aspects to it. There's a lot of reasons why this is a starting point, but it's also how is it enabled by, the other aspects of smart. And so if you go to the value proposition, classically, when we talk about decarbonization, it's been about energy. And if you can improve and reduce your energy use or be a zero net energy building, say, not talking about the carbon metric, you're looking at operational efficiency, you're looking at utility costs, you might be looking at some other aspects, but that's sort of the classic value proposition for it. But I'm going to say that there's a lot going on in the market. They're sort of pushing and pulling us in that direction, again, for why we want to look at decarbonization. So there's declining costs around green energy or clean energy solutions. There's policies, there's incentives, there's things happening and that are resulting in a shift from fossil fuels to clean energy on investment side. There's public demand. The occupants of buildings are going to require it or wanting to see it more because there's an expectation there. And then there's the idea of electrification in the grid. The other aspects of, if you're thinking about it again from the built environment, are going to be related around these sort of aspects as well. And I'm not trying to steal anyone's thunder, but there's sort of a value creation and attraction and retention associated with decarbonization now, at least in Seattle, and I think increasingly other places as well. So positioning yourself for competitiveness in the market for the long term suggests that, again, smart is decarbonization. And then I think the other value proposition or business case that we all recognize is really just looking beyond ourselves and looking beyond, to our families and to the planet. And so for those reasons, we want to talk about carbon emissions in terms of smart. And just to sort of set the stage before I introduce our panelists, there's really just sort of two different sides to it. Classically, there's what we call operational carbon emissions, which relates to the energy that's used by the building, indirectly sometimes based on, where the fuel source is. So it's what's at the meter. And then there's embodied carbon emissions. And I'm going to let Jack talk about that when his turn comes. But this is basically, what does it take to make the building? What does it take to keep the building going from the standpoint of materials you have to put into it, replace things as they age? And then, as you deconstruct at the end of life, how much can you recycle? How much goes to waste? So it's kind of what goes into the materials and to extracting them, manufacturing them and delivering them and building it into the project. So with that, I'm going to stop sharing. And I'm going to ask our panelists to briefly introduce themselves. Alissa, can you please go first? And I can't hear you. Say mute. There, try that.
Are we good?
Yeah, there we go.
Great. I'm glad we worked that out now. My name's Alissa Feucht, and I'm a senior sustainability strategist at Glumac. So my day out is focused on helping owners create sustainable buildings that work. And so a lot of LEED certifications, living building program, fit well, so healthy buildings as well. And just really happy to be here.
Okay. Jack, can you go next, please?
Hey everyone, I'm Jack Rusk, climate strategist at EHDD Architecture, offices in San Francisco and Seattle. I build data models to help understand kind of whole carbon emissions from buildings, operational embodied landscape, et cetera. I'm excited to share some of the results from those today.
Okay. My friend Salone, can you please go next?
Hi, everyone. I'm Salone. I'm Vice President of Development over at Urban Visions in Seattle. We are a privately held development company led by Greg Smith. We develop, hold, and operate our buildings. And because of that, we have overseen several buildings, through inception occupancy and post-occupancy. We've experienced firsthand the pros and cons of our decisions. And this has really helped shape me as a strategist, but shape us as a company to approach each new development with the philosophy of let's begin with the end in mind and what impact are we really trying to create for the future.
Great, thanks, Salone. And then finally, Ron.
Hi, yeah, I'm Ron Fues with McKinstry, based in the Seattle office, a project director focused on existing building retrofits. So yeah, like the tag on the embodied carbon. So, keeping existing buildings going, optimizing them, that's really the focus of the team I'm in.
And the 800-pound gorilla, I might say, going forward, if we're really going to do it. So glad you're here, Ron. So Ron is certainly could be on this panel on his own, but he's also somewhat of a pinch hitter, if you will, or agreed to join, because we originally were talking with Lincoln Ferris of Seattle Colleges, who has a recorded session we'll be looking at in a few minutes. And Ron was involved in that particular project that they're looking at Seattle Colleges. And so he's going to be available to do the follow-up discussion and those kinds of things along. So we do thank you, Ron, for joining us today.
Thank you.
All right. With that, getting me out of the way as much as possible for the next period of time, I'd like to ask each panelist to provide a short presentation to talk about how, what they're doing in their work is leading to reduced carbon emissions, again, from the built environment. So I would ask Alissa if she would like to start.
Oop. There we go. All right, so I'm going to be presenting today on a case study of a project 400 Westlake. So this project is located in Seattle, Washington. Its owners and its developers are Marseille Real Estate, and their big ambition is to design one of the greenest office buildings of its size in the world. And so this project will be about 220,000 square feet of office space over 15 floors, the ground level retail, and really great rooftop amenity spaces, as well as parking for mostly bicycles, but also some vehicles. And a really cool aspect of the project is they're actually working on preserving the existing Firestone building facade. And so they demolished the inside of the Firestone building and built the office tower up while keeping the facade. And so being in South Lake Union, it's pretty heavily populated with tech tenants. And so they did want to make sure that even though they're designing one of the greenest office buildings, that they were designing for the typical tech tenant. So this Marseille Real Estate decided they wanted to pursue Seattle's Living Building Pilot Program. And so this is a really stringent program within Seattle, and but it has some great benefits for the owners. And so by following this program, we have to reduce the building's total energy usage by 25% over Seattle Energy Code's target performance pathway path. And so that's the actual how the building performs path. And so Seattle already has very strict energy codes, so we have to go above and beyond here. Also, we're not allowed to use any fossil fuel for space or water heating, use only non-potable water for non-potable uses. So we'll be collecting all rainwater and gray water on site in order to meet both our flushing demands and our irrigation demands. And the building has to also achieve PEDAL certification under the Living Building Challenge. And so there's great incentives for owners that are pursuing this work. They get up to 25% increased area, FAR, and they also get additional floor height. And so that's typically like 1 to 2 additional floor levels. So what is the Living Building Challenge? Living Building Challenge Pedal certification requires us to achieve 3 of the 7 pedals under the Living Building Challenge. One of those 3 pedals has to be either materials, water, or energy, all of which are pretty difficult pedals to achieve. Materials pedal requires basically all red list free materials being installed within the building, as well as an offset of the total embodied carbon of the building, a one-time offset. Water requires you to be net positive water, and energy requires you to be net positive energy. Our project decided to go after the energy pedal and do it using an offsite energy exception. We are also going after both the place and the beauty pedal. I did want to mention that this project is pursuing Living Building Challenge under an older version 3.1 versus the newer version. And so any of the buildings that are going after this program now, if they choose the energy pedal, the carbon reduction piece is now entangled within the energy pedal rather than materials. And there's also some core imperatives that need to be met with each one of the pedals. So it does make it a little bit more challenging now. So first off, we wanted to set an EUI target for our building to learn what we needed to design to. So we were given a baseline EUI based upon Seattle Energy Code's target performance pathway. And so the baseline EUI is 36.7, and we needed to reduce our energy use by 25% over that 36.7, giving us a Living Building Pilot Program EUI of 27.7. But we can't really anticipate how the tenants are going to be using this space, or for impacts of, say, climate change, or just like a off typical year. In order to show that our building is performing, we have a performance period. And so we can't make the predictions of exactly how the building will perform during that performance period. So we set a target EUI 10% lower of 24.7 that we really wanted to achieve to make sure we were going to be in compliance with all these rules. So in order to make sure that we were designing the building correctly, we used energy modeling. So we use this as a decision-making tool. It helped us determine our envelope parameters. It helped us make our system selections. And then it helped us also establish requirements that we were going to place on the tenants moving into the building. So we wanted to make sure that we were setting the building up with great infrastructure and great systems. And so when the tenants moved into the spaces, they weren't going to have to take basically the brunt of the work to get to our goal of net zero energy and the other stringent goals of the pilot program. And so this helped us establish some requirements for the tenants. So we did have to make some assumptions with our model. Again, we were designing for the typical tech tenant. So we had a pretty dense occupancy of 130 square foot per person, typical occupancy schedule of 8 a.m. to 6 p.m. And then some of the things that we wanted to put on our tenants that we didn't think were too stringent included a 10% reduction of their lighting power densities from code. Also, equipment power densities could be no greater than 2 watts per square foot. We can't be putting too much heavy equipment into these spaces to make sure we are going to be able to offset all of it. Also, some pretty stringent plug load controls to make sure that equipment was turning off when it wasn't being used. And then we do not want the tenants to be straying too far from those space temperature set points that we set, and also wanted to ensure they were installing low flow water fixtures so we could meet that stringent water goal. So we started with a simple HVAC matrix to help us select which systems we should even plug into our energy model. And so we analyzed 5 different system types here and looked at different parameters to see what kind of played out the best for this. If you look at this, the air-cooled VRF system actually scored the highest in this, and that's because its first cost is typically the cheapest out of any of the systems that we looked at, and it also is pretty energy efficient. Coming in second here is the chilled radiant hydronic loop, also known as active beams. So using this first analysis, we narrowed down our selection. So we narrowed it down to both the air-cooled and water-cooled VRF systems, as well as active beams. And these were the three systems that we decided to put into our energy model. So as you can see from this analysis, the active beams was the most energy efficient system, which we already kind of knew, but we were able to see how much more energy efficient. And because the owners really wanted to design the most efficient infrastructure that the tenants could move into, this was the system that was selected in the end. And so it was an active beam system connected to a heat recovery unit that was supplying all the ventilation with a really good heat recovery effectiveness at 75%. And then also some equipment on the rooftop that was supplying those active chilled beams. So we've designed the efficient envelope. We designed some tenant parameters to help us get there and selected the most efficient equipment that we could into the building. How do we go and get to that total net positive energy? Because we're located in a downtown dense urban environment, there's only so much PV that we could install on our building. And so we maximized the amount that we installed on our building. We were actually required by the offsite exception to install it for 75% of the available roof area. And so much of the roof is covered in PV to help us offset as much energy as possible on site. Then we look to the offsite exception and will be installing over like 6 rooftops worth of our building located within the same regional grid in Northern Oregon. And so with the combination of all of that offsite energy and our really efficient systems and some of those passive strategies and tenant strategies, we should be able to get to that 105% offset of total energy use. So for this project, we really wanted to make sure the most important thing was designing for those future tenants. And so the tenants will be able to easily tie into that efficient base building infrastructure, utilize the chilled beams for heating and cooling. Also, they will have some requirements about the energy and the water to make sure that we are meeting those requirements. And then the metering is a very important part of this project. In that post-occupancy year, we just want to make sure we're checking in on the building routinely and everything is working as needed. And if there are any spikes in energy use, we can kind of go on in, fix it really quick to make sure we're going to meet those goals at the end of that year. So I just wanted to say thanks for being here. And I wanted to thank Perkins & Will, the great architects on this project, MSRE, the owner, and then also Lise Crutcher-Lewis, who's doing a great job on the building right now. The building should be in substantial completion in February of next year. So we're really excited to see it built and operating.
Thanks, Alissa. Before we move to our next presenter, I just want to mention, I should have mentioned this earlier, that audience can submit their questions in the Q&A feature that's in Zoom. There's not the live chat. You don't have that access, but you can put them there and we'll be monitoring those, but we will not be getting to them until a little later when we're done with the presentations. So we saw a cool presentation on operational carbon and how to deal with that. Now I think it's time to look at that embodied stuff. And I think Jack has some epic stuff to share with us there. So yeah, Jack, you want to take it away?
Sure. Thanks so much, Tom, and thanks so much, Alissa. Super cool presentation. I might have some things to off here, but I definitely have a lot to learn from the approaches everybody's sharing. I'm going to share my screen. I have a presentation up. I'm going to talk about, Alissa walked us through this super cool planning process, and I'm going to talk about the set of tools available at the very beginning of that planning process to sort of set the intentions and strategies for decarbonizing buildings. And I'll go through some examples of how this has worked out on some of EHDD's projects and how that interacts with things like smart building systems. The tool that we've built to do it is called EPIC, the Early Phase Integrated Carbon Assessment. Early phase, I'll talk about what integrated means. Carbon is the thing we're all talking about here. So this chart, a little bit, I think, especially to buildings, operations, and control people, will maybe come off a little polemic, and it is, but I think like one of our approaches here is to understand the very beginning of a project, its inception, is when really massive carbon reduction potential exists. It's when you can decide whether or not you're going to build a new building or renovate an existing building, whether or not it's possible, say, to eliminate natural gas on site, and a number of other things that once you sort of end up on one path or another, right, decisions become path dependent. We saw a lot of really great tools existing once you have a building information model, once you're in BIM, once you have a building operation like management system, and once you're doing procurement, but this gap existing at the very beginning. This gap is at the very beginning of projects exists for a reason, is because you don't have a building designed yet. There's not good data to describe your building and your approach. So we built data models, a set of data models to help, that are all parameterized to help kind of architects, engineers, building owners, and kind of real estate groups plan buildings and improvements into the future to plan for decarbonization. Like Tom mentioned, we don't just look at operational carbon, especially in places like Washington, where the grid is very clean, you see operational carbon taking up a smaller proportion of overall building emissions and embodied emissions taking a relatively larger portion. So EPIC looks across embodied carbon reductions, things like building less, changing your structural system, specifying lower carbon materials, like reducing office churn and things like this to preserve kind of interior fittings in place, operational measures, building electrification, energy use intensity, lowering your energy use intensity, solar PV on site, and looking beyond the building at site and landscaping measures to either store carbon in living systems or to reduce hardscape area and things like that. So again, this model is built in a way where you can sort of like adjust and plan scenarios to look at both changes in operational and embodied carbon over time. The model is used by about 700 people at this point across a little over 400 firms, part of standard scope of work in a lot of places. And it's been really exciting to see the uptake. A lot of work went into it. And I'm sure sometimes when I reach this part in the presentation, people wonder what it all costs. We've made a kind of significant investment in EPIC over the last couple of years and are committed to offering it freely to close this gap in the design lifecycle. We've been really lucky to get good peer review and support from people at structural engineering firms, mechanical engineering firms, and academic kind of advocacy organizations like the Carbon Leadership Forum that have allowed us to sort of move this, what was originally an internal tool, out into the world free to use, again, for people interested in asking these questions about their buildings. So now to talk some about the data model itself and what it tells us. One thing that is really clear is that early phase decisions and generally the embodied and operational carbon trade-off is really complicated or can be, and data models are a way to help untangle some of this complexity. So I'm sitting here in San Francisco and I modeled a basic building in EPIC, and we see when I model this basic building, about 80% of the emissions are embodied and only 20% operational over the next 30 years because of how clean the grid is versus the kind of materials involved. This has a lot to do with being in San Francisco, because when I do the same parameters in other locations, Seattle, Albuquerque, and Salt Lake City, we see really big differences, both in the proportions of embodied and operational emissions over a 30-year period and in the absolute magnitude of emissions. Some things stand out. In Seattle, where the grid is, really clean relative to a lot of other places in the country, we see a lower magnitude of absolute magnitude of emissions. The same building over 30 years, only about 10,000 tons, versus a place like Salt Lake City, where it's almost 20,000 tons. And operational emissions are almost half of building emissions over 30 years. So this is a way that all these sort of like regional factors, that regional variation, affect kind of, the trade-offs between operational embodied carbon. Even more so when we look kind of beyond just that trade-off and into how we're going to start working towards net zero buildings. This focuses on operational emissions and same set of comparisons. On the left side, you see if I were to plan the same building as a net zero building in San Francisco, I could specify a PV array of about 470 kilowatts, modeled in NREL's kind of system advisor tools and stuff like this to figure out the size of that. And then applying that to all these other scenarios I set up, we see that the same PV system in Seattle actually can't cancel out all of the emissions because of, there's a difference in sort of like solar irradiation patterns, right? That the solar resource is different in Seattle. But in Albuquerque, even though absolute emissions are much higher, the same solar array can actually bring the building to net positive because of the same trade-off between the amount of solar resource available and the operational emissions. I think for a lot of like firms and organizations that do work in more than one geography, it's really important to understand that there's no one-size-fits-all solution. So that what I'm used to here in San Francisco, or people are used to in Seattle or Albuquerque, isn't applicable in other grids and other sort of like climates, et cetera. So that sort of sets out some of the basic kind of, distinctions between places. EPIC also looks within a building to try to identify what pathway to decarbonization might exist. This is kind of results from EPIC looking across 5 different scenarios across 30 years for the same building, trying to understand how different measures stack up to kind of illustrate a pathway to decarbonization. EPIC 2 is only one tool. There's a lot of other tools out there, and the sort of ecosystem of tools is trying to do a better and better job of working together, connecting tools like Tally and EC3, tools like Pathfinder that work in the landscape, Architecture 2030's upcoming CARE tool that looks specifically at retrofits, as all kind of working together across the project lifecycle to plan carbon reductions. Okay, now I'm going to talk really briefly through a couple case studies to try to understand how this stuff actually comes through in a project. This is a recent EHDD project, or rather an ongoing one, the retrofit and renovation of the AIA National Headquarters. We plan for a large embodied carbon savings by reusing existing building. It's going to be an all-electric building with on-site energy generation and off-site energy generation that's based in sort of a community project that provides kind of emissions offsets to the building on site. We used EPIC before we had, even a basis of design really for the project to set out some options for what these could look like. Again, trying to plan ahead into the future and using data models to make sense of some of that complexity. So here's 3 scenarios we set up that we presented to the client before we had a building model when we were still in the very early planning phases to choose the best sort of set of strategies to deliver a net zero headquarters. On the building operation side, I think there's a lot of emphasis on energy, and rightfully so. Here we're seeing this other kind of real potential, which is in our approach to interiors. If interiors, for instance, are replaced every 5 or 10 years, there's a lot of embodied carbon in those materials. One thing we're looking at here is how do we extend the life of existing interiors and interiors to be installed to lower the embodied emissions, right, from building operation. The second case study, one I'm really excited about, is the Sonoma Clean Power Headquarters. This is a community choice aggregator, sort of a clean power purchase kind of group in Sonoma in California. Again, it's a building reuse project. One of the clearest ways, like Tom said, to reduce embodied emissions is to reuse existing buildings. Again, it's all electric. Again, energy generation. But the really exciting thing here is that there's an on-site energy storage that's grid interactive. And there's a whole kind of process here that the engineers did to make the demand response systems that dispatch the battery respond not to a price signal on the grid, but to a carbon signal. So to sort of like refigure the firmware in the energy storage and grid interactivity components to make them responsive to the carbon profile on the grid, right? And not just the price, because sometimes those things line up, but sometimes they don't. Again, using EPIC to sort of like model what this looks like over time, we see the way that over 30 years, this project is able to not only reduce its embodied emissions through things like low carbon materials and building reuse, but also through the combination of energy generation and energy storage and grid interactivity, reduce 100% of its operational emissions, even over time having the potential, right, to have a net kind of generation. And this is a way that we're able to sort of like just like mock up rough models of how all this stuff works together to lower the whole carbon footprint, looking at operational, embodied, and landscape carbon, all in kind of conversation with each other on these projects. Cool. Well, that's a quick kind of soups and nuts of this early phase decarbonization planning tool. And I'm around if there's any questions here or later. Thanks, Tom.
Thank you, Jack. All right, moving right along. I would ask if Salone would like to say a few words now.
Absolutely. Before I start sharing my screen, I want to launch off something that Jack said. So you heard him say that in the Seattle area, we were about 95% was embodied carbon and about 9% operational. And then he said, this is about extending the life of buildings to reduce embodied carbon and the impact over time. So I want to use that as the leverage point to share what I'm going to. Can everyone see my screen? Yep. All good?
You're good.
Okay, great. Thanks. So having said that, this is hopefully to complement everything you've heard, from Alissa and from Jack. So let's talk about what we at Urban Visions are doing. And I've broken out our slides into 4 groups, really just to give us some context as to how we looked at context and why we did what we did and what we did and how we did it. So let's begin with context. For us as developers, we've got 5 stakeholders. We've got tenants, we've got operators, we've got capital partners, the environment, and human health. And to us, all 5 are equally important because there's a push and pull, and if you prefer one over the other, something else suffers. The other part of our context is, all of us are trying to design for today, but we ask ourselves, what about the future? We're always trying to meet current codes, current requirements. And also we looked at, hey, what is it that we know today versus what is it that we don't know? And the other things that influence or impacting us, the old adage of Moore's law, which is technology adaptation is the fastest, social adaptation is net, and the built environment is always the slowest to incorporate anything as far as innovation is concerned around technology. And we're also living in a world today with measurement and verification, which are inconsistent and inadequate. None of this is a judgment. It's just a data point, and we're all trying to navigate this. And then when you're looking at areas to decarbonize, you're looking at embodied carbon, which you heard, Alissa and Jack talk about. We're also looking at location and the impact of that with decarbonization and emissions during operation. So the way we broke things down from a decarbonization, we said, you can decarbonize in present time. And a lot of what Jack mentioned is about embodied carbon, and it is very critical. And we also looked at, how do you do this over time? And a lot of what I'm going to share is about the future and emissions during operations, but the impact over time. So let's talk about the why for a second. Coming back to impact, we felt that in the built environment, there's millions of square feet that even we as developers, we've put buildings out there that become stagnant day one. And it's really hard for them to then adapt to all the future technology or the innovation that comes to reduce carbon. So we also said, with Moore's law, that these buildings, that we don't know what technology is around the corner, and these buildings that even we put out are not built to adapt to the future. So we as a company took on a philosophy. It's a little bit of an audacious challenge, but this was our version of trying. And our challenge is that Urban Visions will not develop a building that becomes stagnant or obsolete at TCO or day one. That's our endeavor going forward. And what we're trying to do is we're trying to bridge the gap between, what gets built and what's coming around the corner. And we're trying to build our building as operating systems. So that's something that we're focusing on. And we're doing this to do 2 things. We're looking at monitoring behavior to save energy and cost and to reduce our carbon footprint, but we're also looking at interoperability and future applications. So let's look at what we did and what we've done to deploy it over this 2.5 million square feet that we're developing as of right now. So the first things we did was we looked at what is our certifications that we really want to focus on that actually have impact. These are the ones we focused on, and what the thing we were looking at was the power of the confluence of all these certifications that then build on each other to really push us also from an innovation point of view. And I apologize, my laptop's just being a little jumpy today. Sorry about that. Here we go. And let's talk about, well, what were the moves that we did? So we made 5 moves, 4 of which were based on embodied carbon and what are the moves that we do today, versus one of them was about the future. What is it that we don't know and what's coming around the corner? So we absolutely went all electric on our buildings, just like Jack mentioned. As at Alissa, we're very fortunate in the Pacific Northwest because of hydroelectricity. And the other decision we made was we wanted to focus on hydronic systems versus refrigerant-based systems. We also look at on-site renewables. Projects have over an acre. One of our projects is over an acre of PV panels. We do a carbon offset, but we try to do that as a last resort. And then we really focus on biophilia as well. And then the most important thing to us, which is what I'm really going to expand on, is network architecture, the infrastructure for future proofing. So talking about network architecture and why this was important and how we broke it down, we said, let's look at our buildings in a way where we can build an efficient backbone and pathway, where this is something that, typically we don't look at in buildings, and everyone does everything in a vacuum, mechanical, electrical, plumbing, and it's redundant and it's costly. The other thing we focused on was bandwidth for future and current processing power. The third was owner cloud accounts, whether we do local servers versus, servers in the cloud. And then also we definitely studied software and machine learning. And this was incredibly important to us because we wanted to make sure we got current and actionable data. And I use those words very, very deliberately. It's not about just getting data, but it's got to be data that we can act upon. And the fifth and most important is being very strategic about security. So let's quickly dive into how we did this. So the hows are going to be based on 3 things. One was culture, the teams, and design. First, we've got to begin with the culture of how this happens. It really does begin with Greg. He has told us, get out there, be curious, go explore. And what that led was into us continuing to educate ourselves, continuing to innovate and incorporate. And it's about agile responsiveness. This is about making real-time decisions. And I can tell you, I think our poor consultants may have a love-hate relationship with us because we may start off with something and we may end up with something very different. But that is something that is very critical, where it comes back to Moore's law, that how do you try to bridge the gap between technological innovation and how slow real estate, adapts to innovation. The second part of this was the team setup. So in order to do network architecture, we hired McKinstry to be the network designers. They teamed up with GASME to work on controls and systems integration. And then we also hired an IT consulting company to break out the networks that were ultimately going to get used with us and the tenants. And then we also looked at commissioning. It's no longer about MEP commissioning, it's what we're calling TEMP. I'm sure you can come up with better abbreviations, but it's about technology, electrical, mechanical, and plumbing commissioning. Sorry. And then the design part. This is really critical to share. Whenever we have bought an iPhone, we don't just buy the iPhone for the apps that are preloaded as of today. We are actually always buying something because of its future processing power and of all the future apps that we can download and what else we can do with our iPhones. I really would encourage us to start looking at our buildings this way, and not just us as designers, but even on the finance and the equity side and the capital side of life. We've been always taught when you design, you go through the 4 phases. But here's another way of looking at design. You're designing, look at your buildings as an operating system and an operating platform. Design for what is it that we know now, but also design for things that are yet to come. And that is something that I would ask us to do, to have a bit of a shift in the way we approach the built environment. So what did we really incorporate into our buildings? And these are the last 3 slides, folks. So just to let you know, what does this network architecture really look like? Typically, this is a lot of how the buildings are designed. MEP does their own work. They each have their own backbone, and the buildings are infiltrated with all kinds of equipment, head-end equipment. And a converged and a well-designed integrated network architecture looks very streamlined. The other part of this is that you also end up with a very clean basis of how you build your platform. You make sure you have firewalls, you have, the different layers as you build up. So there's horizontal integration as well as vertical integration. And then the last part of this is also then how you end up with integrating with your tenants. By the way, the 3 slides that I've shown you, these are just graphical versions of what's actually been put into our CDs under the network architecture drawings. So this is something else that's also well thought out, and we use this to then put into our lease documents as well as in our shell and core matrix. The last thing I do want to just leave you with is a little bit of a philosophy. It's our behavior and our usage patterns that have brought us to where we are today. And really the power of technology is it really teaches us a lot about ourselves. And it'll continue to teach us a lot about ourselves in the future. And that's why in many ways we feel that it's super important to integrate our network architecture into our buildings so that our buildings are still relevant going forward into the future.
Thanks, Salone.
Sorry, I'm trying to stop share to find my stop share button.
There you go.
Folks.
All right. Well, I would almost stop right there and have a conversation with you, but we got one more to do and then we'll go from there. Carrie, our background moderator assistant, can you please present Lincoln's videotaped presentation now?
Hello, my name is Lincoln Ferris, and I apologize that I can't join you in person today. I am here to make a presentation about the Seattle Central College Eco District, and my colleague at McKinstry, Ron Fues, will be there in person, hopefully, to answer questions and to correct any mistakes I've made in the presentation. So with that, I'd like to explain a little bit about why and how Seattle Central College came to create an eco district on our Broadway campus. In particular, we have a campus that dates from 1971 and when it was established, but many of the buildings could date back into the 19-teens. And as such, a key source of our space heating and hot water for the Broadway campus comes from a steam supply that is generated at a fossil fuel fired plant down on Western. And as such, when we engaged with companies like Gordian to take a look at our deferred maintenance costs on our physical plant, we discovered that not only were we at the end of the life, but that we could sink another $12 million to update that steam system, or as you will see, we can choose an all-electric solution to replace it. Now, as such, one of the things that we have chosen to do is to take a look at the fact that we can't escape that if we want to contain carbon emissions, we really have to look at the built environment. It isn't just about convincing people to commute to campus in multiple occupant vehicles or via the light rail line. If 40% of all carbon is emitted out of a built environment that doesn't change over every 8 years like a car does, but has building lives that are 70 to 100 years old, then we needed to take a look at improving our campus and converting to an all-electric solution for the key source of our carbon emissions, which is our heating. Now, as such, one of the things that we took a look at is, as you all know, there are many market forces pushing us in the policy side to take a look at reducing carbon emissions. In particular, for the state of Washington, House Bill 1257 set a set of both targets out in the future, which are fast approaching, but also really require us to take a look at significant reductions in greenhouse gas production from all aspects of how we operate as a campus. And more particularly, the Seattle Building Code has become much stricter, so that if we modify a building and it's considered to be substantial alteration, it now must meet these newer codes. So we took a look at the opportunity, instead of saying, hey, this is a conundrum, because there is no easy state funding source that we can do for energy conversion projects. We looked instead to saying maybe there is an existing program which we can take a look at. And in this case, we have been working with McKinstry for many years using the Energy Savings Performance Contracting WACs to be able to finance through energy savings and through a guaranteed maximum allowable price on the investment, a series of conversions of things like our lighting systems, our heat, air to water heat pumps, that have made us a much more efficient campus. And with that as a model, we started to take a look at, we actually know something about an eco-district. And by that, if you're sitting in the Smart Building Center today for this conference, you're in a building that in 2015, we converted from a 100-year-old older building and highly energy inefficient to one that met the then new building standards from 2012 adopted by the Seattle Energy Code that required us to make it no less than 120% of the energy savings performance that would be expected of a brand new building. Well, what does that involve? Well, among other things, it meant partnering with Seattle City Light on some incentives for financing incentives that were based upon the actual performance of the building, and working with the tenants, in most cases for the 200,000 square feet the college occupies, that would be our students and faculty, to try and teach them about how they can reduce the actual impact in the building by the behavior that they have. So in the core, as we started to take a look at our Broadway campus, the opportunity to engage with our neighbors, the opportunity to engage with Seattle City Light, and to take a look at, if you will, a mini grid that could be expanded over time as new construction and or conversion of buildings is done around us. But more importantly, to take a look at with thermal share in particular, loads can be shifted, if you will, at different times of day between different uses in buildings. And by bringing in buildings that have both residential as well as office and or college use, we could create an effective, if you will, load sharing that would reduce the cost for everybody who engaged with the eco-district. Now, here's a map, if you will, of the college campus on Broadway. And if you notice the buildings in green, other than the MAC, these are the primary ones we are going to build, if you will, a new, energy sharing system within them. The primary source would be air to water heat pumps up on the buildings. But we are also building a very large capacity for thermal storage that would then be piping, if you will, hot water between the different buildings to even out the load, but more importantly, to minimize the number of times we have to resort to an electric resistance boiler as the backup. We've worked very hard through our major institution master planning process to engage with citizens and our neighboring businesses around us with the idea that this is an opportunity that can be, if you will, plug and add it. So if you notice on here, we have future redevelopment of our parking garage for student housing. We have a new academic building we're planning on our north lot next to the light rail station. All of those both become, if you will, nodes in which we can create energy and store it, but also in which we can share and mix loads back and forth for optimization. Now, one of the things that we had to do, and I should say this was not an overnight decision, we have been looking for many years with Gordian's help at our deferred maintenance, and we knew that we had a huge backlog, if you will, in our primary buildings, the 400,000 square foot main Broadway Edison campus. But we also looked at the fact that these deferred maintenance costs would overwhelm any funding sources we have. And we commissioned a life cycle, if you will, analysis of the existing equipment we had in the building with the help of McKinstry to make sure we knew what really needed to be retained and what needed to be replaced. So electrical panels that are at the core of much of this thermal sharing were at end of life, as well as the steam system. We wanted to also get past building by building upgrades and really take a look at a comprehensive approach that would have a 30-year timeline and frankly would then be paid for through bonds that could be issued like a building bond at 25 years to spread out, if you will, the cost of amortizing this capital investment. We don't see ourselves as an energy purveyor, and I want to be really clear about that. We are not a new mini utility, but we do think that by engaging with our neighbors over time, we can bring down the overall cost and increase the reliability of our system for both ourselves and for adjoining property owners. Now, the economies of scale are really something that have been demonstrated in other McKinstry projects that are done in Spokane. But here for us, where we have in the past done building by building, here's a new system, we put new pipes from the steam supply. What we really wanted was something that had economies of scale realized and in effect have one spare, if you will, behind to make sure that everything kept online for as long as possible and minimize the amount of repair services, but also acknowledge the fact that we have a hard time recruiting the specialty trades that can maintain some of this system. And so we are looking at this as a long-term partnership with McKinstry as our support staff, if you will, to maintain and operate the eco-district. The end vision is really both decarbonizing the campus, and we think again that we can realize significant savings. Up to a third of the cost of our bond servicing is going to be coming from utility savings, but also increasing the resiliency of our system and making sure that we are setting aside money again over the next 25 years to replace it. The overall goal is to reduce and achieve a 30-year average cost of $350 to $450 a square foot, and again to keep meeting or exceeding the climate change impact goals the state sets for us. Now, this has been a multi-year partnership, and I want to say we are sort of at this point where we have considered, we've done all the information gathering, we've done the engineering studies, we've finished the economic evaluation. At this writing, as I'm off fishing in Alaska, we now have a guaranteed maximum price for this. And really our next steps are to go to our two sets of trustees here at the local area in Seattle and then at the state to get approval to bring this, if you will, to the legislature for approval for us to borrow under the local program of the state treasurer, where our borrowing costs are about 500 basis points below what it would be for a private industry partner to borrow and construct this on our behalf. And with that, I'd like to turn this over to Ron so that he can answer questions for you. I really welcome this opportunity. I hope you'll follow along as we implement this over the next 2 years. We hope to make this a model that can be duplicated by many other institutions across both Washington State and North America, because we believe this institutional challenge of being not only sort of low impact, but frankly, to be careful and wise with our maintenance and operating dollars and creating new sources of funding in which we can tap for long-term amortization of the cost of these investments really needs to be solid. And as such, we intend to be very cautious as we approach this to be able to prove out as a case study that it works. Thank you so much, and I look forward to meeting many of you in person at the next conference.
Thanks, Link. Sorry you can't be here again, but we're glad we have her on. So if I could ask folks to, looks like we lost Alissa. I hope she can get back on. My first question was going to be for her. Let's give a second just to see if she jumps back in. Anyway, we're going to switch into moderated panel discussion now. We've heard from each of our panelists and really appreciate their different takes on this thing. It's kind of a big topic, at least it is for me, in terms of how I spend my time and think about this stuff. But I'm going to probably seed some questions out here, see how that discussion goes. There's Alissa. See if she gets fully back. And I see there are some questions showing up in the Q&A, and we'll get to those as they sort of tie into the discussion a little bit, and then we'll try to be done right on time. Okay, Alissa, are you fully tech back?
I am fully back. The internet just kicked me out.
Okay, all right. Well, I'm going to go a little bit in the same order, but we talk about this whole thing of decarbonizing, and you're taking on a new building, Alissa, and you're doing something pretty aggressive, even though there are some precedents out there. But in your case, you're going to face this aspect of it that's you said it, putting requirements on tenants. And smart buildings, you think about how do we provide convenience and more services to tenants. You're saying we're going to ask something of you. How does smart buildings help you manage that consumption or manage your tenants, if you will, without sort of becoming this big brother in the process? How do you do that? Can you do that? So I'm curious your thoughts on that, and love to hear from others as well on that topic.
Yeah, so one way we're really trying to set up the project for success is make sure we have a ton of metering in place. And so we basically want to be metering all of our mechanical systems, lighting, plug loads, water, all of it. And so by being able to kind of keep our hands on that at a building scale and by like a floor by floor tenant scale, we should be able to more pinpoint if there are any issues with just too much energy use coming out of certain, basically half a floor. One tenant might be using way more energy than we expected. And so our building operators.
Uh-oh. Well, at least she's smiling. All right. Anyone
I
else
can
want to?
actually, yeah, I can
Yeah.
step in if I may, if
Yes,
that's all
please.
right. I just want to echo exactly what Alissa said, because, as a developer, we are also always having to, negotiate these things with our tenants. And, I think gone are the days where we would cater to what people wanted. But the best part of all of this is even they want the responsibility. I think we're all heading in that direction, where together as us as developers, them as tenants are looking for us. They're looking to us to say, hey, what have you done to date? And to Alyssa's point about monitoring, controls, metering, everything that, even when I was talking about the broader picture of the network architecture, a big part of that is about monitoring, and it's all about the controls and all the systems that we put in a very tactical and strategic way, so that we are continuing to observe our usage, not just shell and core, but also on the tenant side, their usage. And they absolutely, I know, and leases are more and more willing to participate in recognizing here are the energy targets, and we're all equally incentivized.
Mm-hmm. Sort of explaining the fact that as a tenant, you want to go into a building that's all clean energy and net zero. That's great. By the way, that means you have something to do with it yourselves, and helping finding out how to have that discussion, because a lot of people don't think that way. And I don't know if it was Alyssa's or Jack, you were showing some of the breakdown of energy, heating, cooling, lighting, those are smaller pieces all the time. What's left is that big chunk of what is sort of the discretionary or unregulated stuff. So anyway, that's cool. I don't know, Jack, if you want to add anything else to that, or I'll move on.
I would just always add to the metering piece is that energy metering is important. And one important thing too is that the carbon intensity of the electrical grid is different at different times of the day. And this is a really important thing, I think, to start connecting these systems that are really well developed for energy efficiency forward, and to sort of also be able to look at grid carbon intensities. We did this in the Sonoma Clean Power Project, and it was hard, but I think things are moving this direction.
Last year, I think there was a topic where they talked about grid interactive buildings, but, we're seeing now in, the new versions of the energy code coming here in the state, just this whole idea of demand response is certainly, coming back, if you will. And it's going to be interesting to see what kind of strategies emerge there, I think, as we go forward in that. Since we got to you, Jack, I'm kind of curious, you sort of showed the power of this, this epic early tool for planning, and recognizing as I think a lot of us do understand that, you can make the most difference early on, but you still have to design, you still have to construct, and so I guess there's sort of two questions, is there a what next for Epic that's sort of looking beyond what it's doing, or the things that it's going to do that we're going to refine what it's doing? And then what sort of gaps are there in the life cycle, if you will, in the complementary tools that are out there that are available to the AEC professionals who design and construct the buildings? And then, Salone showed the infrastructure, but, for building owners, operators too, what tools still need work or still need to come, or, whatever, I guess. And maybe it's the same answer as the last question, but I'm curious what your thoughts. So that's a big question. And again, hoping other people can weigh in on it.
Yeah, just to kick it off, there's a lot of different ways to slice this pie. And one thing I really appreciate generally about the building decarbonization world is it's highly collaborative. We share data with other efforts share data and methods with us, and we're all kind of like mixed in and going around. This is really important because there's a real need for everybody's sake to harmonize these approaches. Some of the basic ways to harmonize, like there's this kind of effort kind of brewing in the background right now to make sure that all of our spreadsheets have the same set of cells, basically, that the data schema that we're all using is the same, because when those things don't match versus this, that kind of accounting methods, it really wreaks havoc. That's an important one. And then there's also kind of more complicated ones grounded in research, like when we look at building materials from living systems, things like wood, how do we actually quantify their carbon storage? A lot of different ways to do it. Well, what's the thing we can all kind of start to gather around is the best way forward?
So some standardization in how we all think about that stuff. Just
yeah, exactly.
like carbon emission factors for the grid, the same kind of, you've got analogous issues to figure out.
I think that, yeah, exactly. And, one Epic does this thing where it bridges between this embodied carbon world and this operational carbon world, this landscape carbon world, which kind of are still, there's interactions kind of growing between them, but also live in silos. And I think this is another thing, is how do we make sure that, how do we understand trade-offs between these, right? And these trade-offs, in some cases are more well established, where, okay, maybe having a really, high carbon envelope, if you have high blowing agent installation that might save energy, but there's a high carbon investment. That might make less sense in a place where the grid emissions are low. Hey, maybe we can use a little more energy, use a slightly less installation, because the carbon that from the electricity is, these are the sort of trade-offs I think that we're going to hear more and more of in the next couple of years. And it's the sort of thing that EPIC tries to get out. I think one big thing that drives regional variation that I didn't talk that much about too is policy. There's a lot of policies developing, and policy is going to drive, I think, this conversation in a lot of places, especially towards harmonization. So especially, in places like California and Washington, but also nationally and internationally.
Well, yeah, I mean, I'm not going to preview my final question, but we sort of act as leaders, but somehow eventually the rest of the market or the rest of the country is going to follow. And so what does that look like is going to be quite interesting too. And you're right, regulation helps drive those things. Welcome back, Alissa. I had Jack finish your answer, so we'll get feel free to lean in some more as we get into some of these other things. So I guess I want to talk to Ron a little bit for a second here. The existing buildings, I mean, that's a massive I mean, that's where the embodied or the operating carbon is, right? It's in everything that's out there right now. And you've got, buildings that were designed using mid 20th century, early 20th century technology. So, these steam systems, and you've got buildings that have no insulation. I mean, you're sort of in the ESCO world, I think, a little bit over at McKinstry. How do you even get your hands around those things when you start to talk about, decarbonizing? And then how does that, and then I want to get from there, sort of leverage into the financial aspect of it. But if you don't know, sort of technically, how do you guys even think about that? Or is it really no different? It's just to the extent we're trying to go as further than we used to go in the past.
Yeah, I think, definitely. If you go back to energy retrofits, or 20 years ago, it really was about a hitting a certain financial self-funding. Was the term that was often used, and that's really not going to get us where we need to go, because then you're just doing low-hanging fruit. So Seattle Central College has definitely done a good job of kind of chipping away at the building inefficiencies before considering the fuel switch. Not to say you would have to do it that way, but yeah, good point. You don't want to just electrify and ignore the envelope and some of the other issues. Also, historical preservation is also a topic for a lot of existing buildings too. And it's hard to believe that a 50-year-old Seattle Central College building would fall in that category, but it is kind of a unique architectural style, so that also has to be preserved.
Yeah, does the it's not, you mentioned just fuel switching, which is what part of it, but don't you have an inherent disconnect? Or are you trying to maintain, sort of the higher temperature systems in the buildings, or instead of going to a lower temperature, because the heat pump technology is inherently a lower temperature than steam, which implies a lot more work in the buildings? Or is that not how you guys are approaching it for that particular client?
Yeah, that's a really good point. In this case, all the steam is converted to hot water before it's used, but it is at higher temperatures than air to water heat pumps are capable of making. So we have essentially it's a double lift system. So the air to water heat pumps make, say for talking purposes, 100-degree water, and then that it gets lifted further with water to water heat pumps. We're hoping that that's not going to be necessary long term as equipment manufacturers catch up with the demand for higher temperature water, but that's really the state of the technology that you can buy in North America right now.
Okay. Well, sorry for getting into the mechanical weeds a little bit with everybody. That's curiosity as a mechanical engineer, so I had to ask that question. Well, actually, you sort of said it just there, and I'm kind of curious. Other people, we do have clean energy here, and that leads generally clean energy in Seattle proper. If you go right outside the city, that's not necessarily the case with PSE. But the big drive is sort of electrification, and that's sort of the de facto way we're going with everything. Is that all we should be preaching to people for their projects, or is there more? Should we be doing beyond that? I'm just curious the take on that, in terms of the buildings themselves. And that's a general open question.
Do you want me to go first?
Sure, Salone, please do.
I just throw myself in there.
Yeah.
You know, I would say no to don't just look at it as general electrification. If I had to rephrase it, I would say that I think it's important to study your local conditions. It's important to study what's locally available to you, because ultimately the goal for all of us is we're looking for clean energy sources. We're looking for creative ways of, you know, energy sourcing, mixing. And you know, one way that we would at least break it down that at least I have is that, you know, in order to along with studying local conditions, you're looking at energy sources, but it's something that is here to stay. But in order to look at things like that, you know, you've got to create your building in a way that can actually receive it, accept it, and interact with it. So those are sort of the two things that you're looking at. You're looking at, hey, what is locally available? What is clean? And then what is it that we're physically putting into our buildings so people like Jack can do their jobs, or people like Alissa can. And then that's sort of where, you know, we come from. For example, for Seattle City Light, we are 88% hydroelectric, but we're also 5% nuclear. There's wind and there's coal. And along with that, you know, they may have the energy available, but they may not be able to transmit, because transmission from a source to where it needs to come to is also another issue. And that's the reason why I would also encourage looking at things like, you know, local energy districts, you know, grid interactive, efficient buildings. Those are the kind of things that I think we should really be focusing on, along with saying, don't just go all electric, look at what is the cleanest source, and then how do you create an interactive platform that then allows for that to happen.
Yeah, it almost sounds like, you know, Ron, they're doing that sort of district solution as an existing, to deal with an existing campus, but you can actually consider that for new campuses as well as a way to solve some of the issues. I guess I'm asking that as a question too. Alissa, you know about this stuff too. What do you think?
Yeah, I mean, definitely want to look at, I guess, establishing more of those like microgrids. Think about it more at like a building or campus scale, not necessarily just a college campus, but maybe how buildings that are located next to each other can interact with each other. You can think about it beyond energy too. You can think about water resourcing. How can other buildings support each other water-wise, health-wise? There's a lot of different things that you can start like scaling. But yeah, I do think we need to think a little bit smaller scale and then be a little bit more interactive with the grid when we design our systems. Electrification works great here, but yeah, not everywhere.
Tom, this is Carrie, the disembodied voice. You have a question from the audience that sort of relates here that I thought I'd just throw out. It's a little bit specific, so, you know, feel free to let me know if it's too specific, but a question from Krista: how does one explore and determine if an eco district can be established, and how long does it take to implement? So I think panelists have sort of been touching on this and handled some of the question, but you could take it a little further.
Yeah. So how long does it take to implement something like that, and first establish whether there's a case for it and then implement it? It feels like, Ron, that's probably a good place for you to start.
Yeah, absolutely. It can't, the assessment phase, you know, honestly is probably 6 months. And then the development phase can go as fast as the client is ready for it to go. You know, in the case of, you know, Seattle Central College, you know, with funding being the way it is for community colleges, they went on a much slower scale. So, you know, we've really been evaluating this for a couple of years. And then as far as the construction phase goes, everyone's aware of long lead times. Right now, our longest lead time item is switchgear because heat pumps draw more power than gas or steam. So new electrical switchgear is 70 weeks. So that's really driving the schedule right now. We're working on seeing if we can get that expedited. We've got one manufacturer that thinks they can do it in less than a year, but still a year is a long time. So our expectation is that probably about a year and a half from now, it could be done.
You know,
So
so, yeah.
it's not your LED lighting retrofit timeline for sure.
This might be a yes or no answer from all of you guys, but I want to hear about it. So what you sort of said there, Ron, was that there really isn't necessarily technical barriers to decarbonization anymore, at least not for operational, at least not for your project. Are there technical barriers when you start to think about this? And you know, I mean, I'm thinking about embodied carbon again. It's like, there's got to be some stuff there that we haven't quite figured out yet, but also operational. I mean, there's, you know, is there topologies that make this more difficult in terms of building types? So what is it technically? Are there any technical hangups anymore? Are they not? I guess I'm asking that question. I'm curious thoughts from everybody on that one.
I could pick up the embodied carbon piece for a second.
Yeah.
There's so many ways to bring about embodied carbon reductions that sometimes I think if you have very complex approaches, yeah, you can run into some problems. The very simple things are possible too. On a recent project Fues, for instance, we substituted steel trusses for just gang nail wood trusses, right? Very simple, off-the-shelf components, lower lead time, less expensive, and way lower embodied carbon. Another clear embodied carbon reduction that we've talked about a ton today is reusing existing buildings. Technical challenges exist to reuse existing buildings efficiently, like people have pointed to today. But, you know, it's not rocket science either. And so I think there's a way that a whole carbon thinking where you look at operational embodied carbon together. There's it's not just low hanging fruit. It's these really these synergies that we can create through the different approaches for operational embodied carbon. So, okay, there's always going to be technical challenges out there in the distance, but there's so much right in front of us for us to capture and move this forward.
I would just add to one thing. We talked in terms of, when you talk in terms of operational carbon, I do want to sort of spend a little bit of time on that, because operations is not just about operations today, but it's the impact of operations over 20 years, 30 years. And the only way that we can really impact this is if we really start to track and understand how are we using that building. And that's why, when we talk in terms of impact over time, that embodied carbon may have an impact today, and it does. But it's also then operational carbon that starts to build up, even if it has low impact starting off, but with time it can really build up. And so, the importance of, I would say, if there's one move, if you have a limited budget and you really just can't do anything to it, the one move I would request people whether you're retrofitting an old building or starting new construction, is spend money on control, spend money on monitoring, on metering, sensors, because the data, the quantifiable and executable data that you can gain from that will really help you make the right decisions to then offset carbon in the right way, as opposed to just flying blind. So those would be the things that I would really emphasize on.
Thank you. Great point. Just giving a second if anyone else wants to say anything to that. Going back a little bit here. Well, actually, what we haven't, I guess I'd like to talk a little bit more about in the time we've got actually ask you guys to talk a little bit more in the time we've got sort of, value proposition and financing and how these things get done. And, that leans in the direction of, Salone again, sort of what, there's things on your pro forma, there's things on your discounted cash flow analysis that are no brainers, but some of this stuff is outside of that. And I know you talked about as, some of the values have driven, urban visions to do things just because they're the right things, but there is still that balance sheet. And I think it's the same with Seattle colleges. They're trying to, look at what debt they can take on and those kinds of things. So I'm just curious, there's sort of the things you can do that sort of show a clear payback, but you're sort of stepping beyond it to get to a fully decarbonized state. Jack, you talked about some big moves you can make, which said to me, the 80-20 rules at play. There's 80% you can go after, but if we're truly decarbonizing, there's that little bit more. So I guess that's why I'm kind of want to throw the financial question out there a little bit to Salone and maybe Ron talking about it, speaking for the Seattle colleges, and how you guys sort of view that part of it and the value proposition associated with making choices like this.
Yeah, I would say I just want to I'll stay on the 30,000 foot level. One of the things is, we're starting to see this happen more and more, that the underwriting for an investment, people are looking at ESG more to say that hey, what are you doing? However, the tripping hazard that I would watch for is, let's not make ESG what the word sustainable became. No one knew what sustainable meant, and so my request is, whenever there's financial underwriting, let's fix quantifiable metrics, continue to educate ourselves. So there is that aspect. There is another move that we're finding is you've got your traditional lending institutions, and when you do go out for loans, they're a little skeptical about second loans that support it and non-traditional sources of funding. I think it's easy to kind of find that one loan non-traditional, but it's really hard to get them to work together. So I think in some ways, financial institutions also need to step away from the same old way of doing business and really look at coupling different sources of capital. So that would be another request. And then there's always policy, and I say this also, with respect to the challenges that even policymakers have, because as developers, we are looking for tax breaks, we are looking for incentives, but we also want to make sure that when we get these incentives, we're not, what do you say, that you're not robbing Peter to pay Paul. And so those are, I would say, breaking it down into those three areas financially is it would be nice to see some change or innovation.
Great, thanks. Public clients, Ron, is it the same answer, or is it how do you look at it representing your project?
Yeah, I think as we're talking about deeper retrofit projects, it really is a 30-year financial model is what Seattle Central is looking at, and a 10-year or 15-year financial model, it's not going to be a good story. These really are longer, still cost effective, largely, but on a longer time horizon, and with the impact of carbon cap and invest and some other things. I mean, there are some new things coming in. There are also some mandates, some unfunded mandates that need to be factored in. Interest rates are rising, but it appears with the Inflation Reduction Act that maybe funding sources are improving somewhat, especially for public entities. So I guess all those things being said is you can't say the financial analysis until after the engineering is done, because you need to make sure that you're doing those in parallel and continuing to refine the financial analysis as the engineering is getting refined, so that you don't wind up with a study that is on the shelf collecting dust at the end of the effort, because no one likes that.
Totally. We've got about just over 10 minutes left. I'm going to just ask Carrie, is there any question from the Q&A that you want to put forward before we go to final question?
Yeah, sure thing. There are a lot of questions in the Q&A, but I saw one that I thought covered a topic that wasn't addressed yet, and this one goes to Salone. So you had mentioned that security is a top 5 design direction. This question comes from audience member Ernie Beck. And the question is this in reference to physical security, data security, or both? And how are you addressing one or both elements?
Yeah, it is about, actually both are critical. Let's talk about, I'm going to first briefly talk about physical security, and then I'm going to talk about data security. So, it's funny, we're actually building this, or we're going to break ground on the 6-building campus over 7 acres. And so, when we talk in terms of physical security, it's this weird mix that we have about, hey, how do you approach this? How do you make it seem open, but then also, still give a sense of, hey, I'm safe when I'm there. So there's that aspect. And then there's the access, the digital world of, access cards and so on and so forth. But really what I was talking about here was data security. And I do want to, and I'm glad you brought that question up, because here in some ways it's a bit of, it doesn't make sense. It's a conundrum, right? We talk in terms of converged networks and network architecture and a well-designed integrated system. But what that means is that a lot of these systems are not talking to each other. But that also creates a lot of vulnerability for us from a data perspective. anyone hacking at one end can get into other things that they really shouldn't. And that is the reason why, you know, instead of just letting your traditional MEP approach that we've always had to, hey, everyone is doing their stuff in silos, that is why when you do decide to take on a team to do network architecture in your buildings and make it as common as you would when you're designing electrical systems or mechanical, is because now you're being tactical. Now you're being strategic, and you're starting at a concept level to say, how am I breaking out security? Where are my firewalls? How am I protecting data when a tenant system integrates with a shell and core systems? When you actually take a tactical approach to strategy, to security, that's when you're actually making something more secure. And that's why, if you're going to hear me sounding like a broken record when I say, please, if you make one move in your buildings, if you can't do something today to decarbonize, do it, at least put in network architecture, because with a great platform like that, you're addressing security, you're addressing decarbonization over long term, you're allowing for future integration of technology to come that even we can't imagine today.
Great. Carrie, another one? Take another one, and then we'll go on to the final.
Yeah, absolutely. So I know Alissa, you tried to answer a question around tenant related pieces of this, and there is one in here that I think is a really interesting one. So let's give it another go. So can you talk a little bit more about how tenants will be required to regulate their energy use? Will it be in the residence manual or a tenant lease?
Yeah, so through our energy modeling process, we kind of figure it out, some parameters that we basically need the tenants to meet in order for us to meet these strict energy goals, or have to install an even bigger offsite array, which is not how we want to do it. We want to educate the tenants, make sure they're on board with it. They know they are moving into a building that is pursuing these certifications. And so these are going to be requirements written into like the tenant lease and be expected of them. And we're hoping we're not going to have to do a lot of just like parenting. And so that is why there are going to be the smart technologies and the meters set up so they can be a part of it. And we've talked about incentives for each tenant to like even incentivize them using less energy than expected. And so ways that they can do that, obviously through reduced rent rates and things like that. And so we are trying to make them part of the process. But yeah, it's a difficult puzzle piece within there.
Great. Okay, in the interest of finishing on time, I'm going to now switch over, and I'm going to ask that each of our panelists take a stab at the following question. Let's picture ourselves in the coming future at an SBX event and having the similar theme as the primary topic of discussion. And so we're talking about decarbonization. We're at an SBX event, and the question would be: what are they going to be talking about? And so I'm going to ask each of you sort of what is the biggest positive or negative change you expect or hope to see 5 years from now as it pertains to this topic. And so I'm going to go in the order of the presenters again, and ask Alissa to take a stab at that one first.
Yeah, so my hope is we move away from Seattle Energy Code and do a Seattle Carbon Code. And so a code that is all encompassing is my hope, and something that I've been trying to help push through the city, so we can make sure that we're tackling not just the operational carbon, but the embodied carbon, the transportation carbon piece all in one, rather than focusing on it bit by bit.
Yeah, and I remember I should have brought that up. I remember Salone, you brought up that transportation piece as well. And we didn't sort of come back to sort of saying that's the true hidden one that we don't actually want to tackle very much, but it's quite important too. Let's see. Well, thanks, Alissa. Jack, do you want to?
I love that, Alissa. And maybe piggybacking off that or building from it, I would love the conversation on decarbonization to really start to bring in all the co-benefits of decarbonization. When we talk about electrification, talk about occupant and community health. And when we talk about time of day emissions, talk about social equity, because a lot of those peaker plants, right, are in sort of like disadvantaged communities. In so many ways, like the conversation about carbon isn't an accounting exercise, right? It's also has really clear social implications and co-benefits. And I think I'm really excited for those to become more central to the conversation about decarbonization.
Yeah, you bring up an excellent point. We didn't talk about the equity issue associated with decarbonization at all. And people are talking about that. Not to get onto it too much, but if utility costs go up, we know who gets it the worst, right? And we know who has the worst buildings. And so it's a big topic on its own. Maybe that's in future SBX. I don't know. So Salone.
I'm going to go with 5. I'm going to stay on the positive. You said positive, negative. So I'm going to stay on the positive, and I'm going to focus on 5 things I would love to hear more of. One is continued focus on network architecture and the importance of that, and the strategic application of that. I want to hear about innovation and retrofitting. We've got to see more and more of this as well, because all of this leads to decarbonization. Talk a lot more about resource mixing, about both between public and private renewables. And then I really think that everything that we can do doesn't work if we don't focus on our operators and building engineers. I think that as a profession, it cannot be in the back burner anymore, that they have to really be in the forefront. And then our financial industry, both with innovative financing strategies, and that they are at the table at this conference, hand in hand with the designers.
Yeah, we always say, gee, it'd be a great conference if we could have building owners at it. We have you here today, but really behind you guys is that, and we forget about that sometimes. Well, those are great points. Thanks, Salone. Finally, Ron, do you have a hope or an expectation in 5 years of what you would think we'd be talking about?
Yeah, let's see. I'll do a technical and a non-technical. Technically, the heat pumps that are available for existing buildings are not up to the task, and it would be great if Europe and Japan would look to North America and say, wow, we want what they have, rather than us saying, well, when are we going to get the cool products that they've got over there? I think that would be a hope in the next 5 years, and there's some funding coming for that. And then I guess another hope would be maybe clients talking about what they have done rather than what they're going to do in 5 years. I think there are a lot of wonderful promises out there, and I think it'd be great if there could be more competition about what have you done in 5 years, because that's enough time to get some stuff done.
Great, fantastic point. I'm going to add my own little answer on this. I've been using this one for years. Is that I hope in 5 years or at some point that I'm out of a job when it comes to decarbonization, because everyone's just doing it and it's part of the mainstream, and we're just kind of like, it's happening. And so we're not having these, this is not a high-end conversation anymore because everyone has embraced it. So anyway, that's my thought. Want to thank everyone who attended this session, the people that we still see quite a few in the room. Want to thank our panelists again, and want to thank the Smart Building Center for making this happen and running the tech. So with that, I'm going to give everyone a few seconds back before noon and say, take care, do well, do good. Bye-bye.